Hello, everyone, and welcome to this workshop about Git. My name is Jenna, and today I'll be giving you an intro to version control. Here are the link to the slides in case you want to follow along, and in case you want to read about this more in depth, there is a link to the README on the bottom of the slides as well. So let's start off with an introduction about Git. What is Git? Git is a distributed version control system. But what exactly does that mean? In simple terms, it's a kind of system that brings a local copy of the complete repository to every team member's computer so they can commit, branch, and merge locally. Don't worry if you don't quite understand what committing, branching, and merging mean yet. But what else can Git do? Let's think of the history feature available in Google Docs. Everyone wanted to see who was contributing to the group assignment when they edited the document and what changes were made. Git provides such benefits. Just like how anyone can open the same Google document on their laptop, multiple people can gain access to the same repository with Git. However, unlike Google Docs, you can't see changes being made instantaneously. Instead, you can only see the changes made after polling, and you can only let other people see your changes after making a commit. So if you look at the picture on the right, you can see the version history available in Google Docs. You can see who made what changes at what times, but Git is a little different in how it works in that you have to purposely publish your changes in a way. And usually, instead of multiple people on like the same published change version, it'll just be one person. So what are the benefits to Git and why would you want to use Git? First of all, Git offers the flexibility to work offline. Most operations, except pushing and pulling, need only local files and resources to operate, so they can be done while traveling or away from home or an office. Contributors can view the running history on their hard drive, so any changes will be made in their own repository. Second, Git provides reliable backup copies. When a team member clones a repository, they essentially create an off-site backup. So if something catastrophic happens, like a server crash, every team member's local copy becomes a backup. Third, Git provides fast merging and flexible branching. Because systems don't require remote server communication, code can be quickly merged. A distributed version control also allows software development teams to use different branching strategies, a feature that isn't possible with a centralized system. Fourth, Git has rapid feedback and fewer merge conflicts. A distributed version control system makes branching easy because having an entire repository's history on their local workstation ensures that they can quickly experiment and request a code review. Merge conflicts are less likely because contributors focus on their own piece of code. Furthermore, having easy access to the full local history helps developers identify bugs, track changes, and revert to previous versions. Last but not least, the available support you get from Git is incredible. In addition to its core functionality, Git also provides a number of tools and integrations that make it easier to use in the development process. For example, many code editors and IDEs have built-in support for Git, allowing developers to easily view and manage their Git repositories from within their development environment. Git also integrates with a number of popular code hosting services, such as GitHub and GitLab. These services provide additional features for managing Git repositories, such as issue tracking, code reviews, and collaboration tools. Since you understand what the benefits of using Git are, let's talk about the terminology we've come across, such as pull, commit, branch, and merge, that you might not understand just yet. To start off, let's talk about a repository. A Git repository is a directory where all of the files and folders for a project are stored, along with their entire history of changes. There are two kinds of repositories, a local and a remote repository. A local repository is a copy of the Git repository stored on your local machine, while a remote repository is a copy of the Git repository stored on a remote server. A local repository is where you make changes to the project and commit them to the repository's history, while the remote repository is where you push these changes so that other developers can access them. The repository is also the .git folder inside a project. It tracks all changes made to files in your project, building a history over time, meaning if you delete the .git folder, then you delete your project's history. Within the repository, there are branches. Branches allow developers to work on different features or aspects of a project independently of each other, without affecting the main branch of the project. Think of a trunk as the main line of code and branches as independent lines based on the same source code. Every single repository has a main branch, aka the trunk. The main branch is the branch that contains the latest working version of the project. You can add feature branches, aka the individual branches, to your repository in order to develop new features for your program. A branch titled messaging would include code for a messaging feature not yet vetted to run on live servers, but maybe your branch's name can be more descriptive. You must pull from the main branch to update your local repository and see other people's code. Pulling changes from the central repository involves downloading the changes that other developers have made to the central repository and incorporating them into the local copy of the repository. This allows developers to keep their local copy of the repository up to date with the latest changes. After making changes on a branch, developers must commit their code. With every commit, Git takes a picture of what all your files look like at that moment and stores a reference to that snapshot. A commit is created every time work is saved. If a file hasn't changed from one commit to the next, Git uses the previously stored file. Git commits provide a way to track the progress of a project over time and to easily revert to an earlier version of the project if necessary. To allow other people to see your updated code, you must push your code to the central repository. Pushing changes to the central repository involves uploading the committed changes from the local repository to the central repository. This allows other developers to access the changes and incorporate them into their own local copy of the repository. After you push your code from the branch you have created, you must merge the branches. Merging, as the name suggests, is the process of combining changes from two different branches into a single branch. This is necessary when multiple developers are working on the same project and have made changes to different parts of the code. Git provides tools for automatically merging changes, but conflicts can arise when two developers have made conflicting changes to the same file. In these cases, Git provides tools for resolving conflicts and manually merging changes. Maybe you kind of understand the workflow from reading the definitions of the terminology, but let's go over it in a simple, clear manner. Git has three main states that your files can reside in: modified, staged, and committed. Modified means that you've changed the file but have not committed it to your local repository yet. Staged means that you have marked the modified file in its current version to go into your next commit. This modified file goes into the staging area, which holds all the changes you made to your files that you want Git to include in your next commit. Committed means that the data is safely stored in your local repository. Let's get started on the actual work process. So a typical work process might look something like this. You will pull from the main branch, then create a branch, do some work on that branch. You'll add those changes to be slated into the next commit, and then you'll commit those changes, push those changes, you'll do a pull request, fix any merge conflicts that happen, and then finally you'll merge your branches together. Let's first start by installing Git. The commands listed on the slides will start with a $sign, but when typing the actual code, do not include the $sign. So for Mac OS and Linux, you'll want to open the terminal or command prompt, and then you'll want to follow the instructions on the screen to install it. For Mac OS, you'll just install Homebrew. It's linked on the slide. The link is also brew.sh, I believe. And then after that, you'll want to go into the terminal and type brew install git. And for Linux, you'll just open your terminal and type sudo apt-get install git-all. And then for Windows, Windows has a direct installation. On the slides, the exe file is linked on the first bullet point, but if you happen to be watching this workshop a long time after the hackathon has happened, you'll want to use the second link to find the latest release version of Git. And then for others, if you want more detailed instructions on how to install Git relating to your own OS, you'll want to refer to the page linked in the other section. And after you install Git, you will want to configure Git. You want to configure Git so Git knows some things about you. Git wants to know your information. If you work in a repository with others, Git can use the information to list who created what changes at what time and how to get in contact with them. So to set your name in Git, you would use the command listed below, git config -- global user.name. Here I have John Smith, but you will want to use whatever your name is. And to set your email in Git, you would do git config -- global user.email with whatever email you want it to be. And then afterwards, you'll check your information. You can check your information by going git config -- list. Okay, let's do a small demo of what we talked about. So I have a MacBook, as you can probably tell. So you will want to, so for me, I will want to go to Homebrew, brew.sh. And then here to install Homebrew, they give you this link, copy paste. So you'll press the copy button, and then you'll want to open your terminal. And then this should open your terminal. And after that, you'll just want to paste it in. After you paste it in, you should press enter, and it should download Homebrew for you. And then after that, as listed on the slides, we'll want to install Git using Homebrew. So the command for that is just brew install Git. You'll just type it in, press enter, and then it should download for you. For Linux, you'll do something similar where you'll open the terminal and type in the command prompt. And for Windows, as mentioned earlier, you'll have a direct installation. And then you will want to configure your information on Git. So if you want to set your name, you'll do git config -- global user.name. And my name is Jenna Wei, so I'll put that in here. And then to set your email, you will do git config -- use -- global user.email, and you'll do your email. I will put my UCLA email. Done. And then to check that you got the right information, you can go git config -- list. And then here it'll say what your username is and what your user email is. And that is it. Okay. All right, next, let's talk about GitHub. So we know that you can collaborate with others using Git, but how exactly do we go about doing that? The answer is simple, GitHub. What is GitHub? GitHub is an internet hosting service that uses Git for software development and version control, and is commonly used to host open source software development projects. Essentially, you use GitHub to create online repositories so that you can save your commit history and share your repositories with others. GitHub provides useful features including bug tracking, software feature requests, and task management. How do we set up GitHub? Everyone on your team has to create a GitHub account. You may sign up for a new account on their website, which is just github.com, preferably using the email you use to configure Git. Now, one person on your team has to create a local repository and a GitHub repository and link the two repositories together. To do this, you would follow these steps. First, you would create a GitHub repository on the website, github.com/new, and then make sure the repository is public and do not touch the other settings. Then you would create a repository on your personal device in the folder of your choice with the command git in it. And then you would create a commit in this repository by adding your changes, git add dot. Note there are different git add commands that do different things. Git add dot adds all the files in the directory. Git add asterisk adds all the files in the directory except for files whose name begin with a dot, so like the hidden files. And then git, you can also add individual files by doing git add file name, whatever the file name is, and that would just add a specific file. And then next, you want to commit the file. So you'll do git commit -m with a message. The message is usually a short description of exactly what changes you've made. And then last but not least, you'll bind and sync the GitHub repository to your local repository. And you'll do this by adding a new remote connection to the local repository with git remote add origin with the GitHub repository link. Then you'll rename the master branch to main with git branch -m main. And then you'll create an upstream tracking branch with a lasting relationship to the main branch with git push -u origin main. And then everyone else on the team now has to get a copy of the repository on GitHub onto their own personal devices. You can do this with the git clone GitHub repository link command. the URL is the same one used in the earlier one. The GitHub repository link is the same. And then you'll be all set. Now let's demo that real quick. So I will assume you already have a GitHub account. So what you want to do is create a new repository. So github.com/new. Here's my account name. For the repository name, I'll just do git demo. And I'll say it's available. You want it on public and you do not want to touch anything else. So you go create repository. And now you'll want to create a repository in the personal folder of your choice. Okay. We have the demo file linked in the slides, and I have already downloaded it. So we have the demo file here. You're gonna want to move this into a folder, a separate folder. You don't want this in your downloads folder. So I have a demo folder pre-created in my desktop. So I'll just move my demo file into my demo folder, and here we are. And next, you want to open this in VS Code. So now that we're in VS Code, we're gonna want to open the folder. Here, open the demo folder, and then you'll see you have the demo file here. The demo file also contains instructions in case you're feeling a little lost. We've done up to like this step, and then we're gonna want to type in the terminal that VS Code has git init to create our repository. I'll just type git init and make sure the folder name here is the folder that your file is in. And then as you can see, after you type git init, it says initialize empty git repository in whatever folder you're in. And after that, you'll do git add dot to add the files. And then you'll do git commit with a message. Since I just have a demo file, I'll just do demo file for my message. Okay, and you will want to bind and sync the repository to our local repository. So we'll do git remote add origin, and then the repository link. You'll want to go here, and it shows you your link. It also has instructions down here. It's basically the same thing. Here, oh, I want to paste it. Don't forget a space in between. Enter, and then after that, we'll do git branch main and git push new origin main. There, and then now you can see that it has successfully pushed it to our GitHub repository. So if you refresh this, it should show your demo file. All right, now everyone else needs to clone the repository onto their own devices. From this, they'll go to their actual terminal, you can see here, and they will type in the command git clone with the repository link. It's the same one we used earlier. And then it should clone the repository into whatever folder you're in on your terminal. Okay, and after that, you're basically all set. Now let's do a walkthrough of what the actual work process would be like when you're collaborating with your team members. So this is basically just the code version of what we talked about earlier. So you'll go to your main branch, you'll pull, you'll go to a new branch, and then you'll add whatever changes you've made, you'll commit it, you'll push those changes, you'll do a pull request, you'll resolve merge conflicts, you'll merge your pull request, and everything will be great. So let's demo that right now with our demo code. So we're done with this part, and then now we're down here. So we are already on our main branch, but let's pretend we want to move to our main branch. So you type git checkout main. It's going to say you're already on main. Great. And then you can also see what branch you're on. On the lower left corner, if you use VS Code, it says main. And if you have some changes if you have some changes made, it'll have an asterisk next to the main. Okay. Now let's pretend someone put some changes on our repository and you're on the main branch and you want to pull. So you'll do git pull. It says we're already up to date. Great job. Now let's make some changes to this file. Create and switch onto a new branch by typing git checkout branch name. For the branch name, we'll just do testing since we're just testing right now. And then I have this chunk of code that I've provided, but we want to replace the code with something else. So let's delete this text and then replace it with something new on. Let's go, I'm an all-star. Then I'll save it. And then I'll add my changes with the command git add. But there is another useful command available that Git has, which is git status. It just shows you the status of your files. So we will, let's test it out. So git status, and it says I've modified the demo file. Yeah. And then we'll just git add. And then let's check git status again. It says now it's green because it says changes to be committed because we have added it. We have added it. So, and then it says changes not staged for commit in the previous one. But now it's changes to be committed. So we added it, and then now we're gonna commit it. Like git commit m, and then the message, I'll just do I am an all-star. And this message is usually a short description of what changes you've made. We didn't make much changes, so that's why my message is so short. And afterwards, after committing it, we'll push it. So we go git push u origin and our branch name is just testing. And then we've pushed it. You get a link to create a pull request, but right now we're not going to be looking at that just yet. We'll be going back to it later. Right now, we're going to do a little bit of role playing. So pretend you're someone who's also making changes to the same repository, except this time you're editing the main branch. So you want to go back to the main branch by typing git checkout main. And you can see on the main branch, it's still the old text that we used to have because the changes that we made were on our separate branch, the testing branch. Okay, so now we're back on the main branch. And then we're gonna edit this section of text again. This time we're gonna just type check. Okay. Okay, we're gonna add commit and change. We're gonna add commit and push our changes again. So we're gonna git add dot git commit frac. And instead of pushing with the longer line of push code, we'll just do a simple git push. There we go. And then so you'll see a lot of text, but now we want to go back to our pull request. So we're pretending we're like the first person again now. So we'll go to here and we'll do a pull request. It says, I'm an all-star. In this write section, you'll usually write some more specific description of what changes you've made. We'll say, changed text to I'm an all-star. So you want to create a pull request. And then, oh no, we have a merge conflict. Okay, if you happen to come across any merge conflicts, you will want to resolve it by pressing this resolve conflicts button. You can resolve it through whatever code editor you're using or GitHub, but for simplicity's sake, we're going to use GitHub. So here it shows the testing branch, and then on the testing branch we wrote I'm an all-star, and on the main branch we wrote Shrek. So here are the two conflicting changes, and we want to make it so they're not conflicting anymore. You can choose to keep one, choose to delete one, or you can choose to combine them. I'm going to combine my changes because that's what I want. Okay, make sure you delete these things. They have like some arrows and it says the branch names. You want to delete those so your changes work. So we have I'm an all-star by Shrek. And once you feel like it's good to go, like, yeah, this is what I want, you'll mark as resolved. After you've marked as resolved, you can commit your merge. And then after you commit your merge, it finally says this branch has no conflicts with the base branch, and you can merge your two branches together. Another feature GitHub has is that you can require approval from specific reviewers before merging. This is just so people can check the work you've done and see if it's good work. But since this is just a demo and it's just me, we don't have any reviewers. So we're just going to go ahead and merge the pull request. we go, confirm merge. Yay, it says pull request successfully merged and closed. The testing branch can be safely deleted. I'm gonna go ahead and delete the branch. And then now if you look at the code here and check the demo code, it will say I'm an all-star Frank. Okay, but we wanna go back to VS Code, and when we go back to VS Code, you can see that even though we made the changes on GitHub, it hasn't showed up in VS Code yet. So why is that? Well, that's because we need to do a poll. So we are in the main branch right now, and we're gonna do a git poll. Okay, we've successfully polled. Now it says I'm an all-star by Shrek, and then that's it. Hopefully this demo walkthrough was helpful in guiding you to understanding how Git works and the many Git commands you have to use. If you have any further questions, you can read the README or ask any officer to help you further. Okay, let's go back to the slides. We are done with our demo now. And then now I have just a few slides left. 2 of the slides are just Git commands. I think are filled with the more frequently used Git commands. There are a ton more, but just know like there's about like 10 that gets used the most, and here they are. So if you want to verify if Git is installed, you can do git -- version. If you want to show the changes made since the last commit, you can do git status. If you want to create a repository, you can do git init. If you want to create and switch to a new branch, you'll do git checkout -b with the name of the new branch. If you want to switch to an existing branch, you'll do git checkout with the name of the existing branch. If you want to add all current changes to the next commit, you do git add dot. If you want to commit your changes, you'll do git commit -m with a message about whatever the commit is. And if you want to push, you'll do git push -u origin branch name. And if you want to pull, you'll just do git pull. Next, here are some extra resources. The first one is Git documentation. It is a very, very long list of all the possible Git commands. I think it's useful if you're looking for something pretty niche. Next, we have the Git cheat sheet. This is a list of more commonly used Git commands. So they're probably the commands you're using the most. And then next, we have Git textbook. If you want to read more about Git, understand Git more thoroughly, there is a textbook available for you for free. And then next, we have the ACM hack officers. If you have any questions, we will do our best to answer them and to help you. Thank you for watching our presentation, everyone. I hope you learned something.